I'm back with a new video, and this time we'll discuss about the Google Cloud Compute Engine, also known as GCE. So let's jump to the agenda. We'll discuss about what is Google Cloud Compute Engine, what are its features, different machine family and its types, internal and external IP addresses with respect to GCE, and the static IP addresses, which is the most important for this. And at last, we will see ways to reduce the number of steps in creating your virtual machine instance. What is compute engine? Back in the days, in corporate data centers, applications are deployed to physical servers. But now question arises, where do you deploy applications on the cloud? And answer to this question is you rent virtual servers, right? So virtual machines are also known as virtual servers in GCP. Compute Engine provides ways through which one can provision and manage these virtual machines. So, in general, GCE is the infrastructure as a service component of the Google Cloud Platform, which is built on the top of infrastructure that runs Google's search engine, Gmail, YouTube, and other services. Google Compute Engine enables users to launch virtual machines on demand. Now, let's talk about the features of Google Compute Engine. So, GCE is a virtual machine service that offers many features, including the compute engine provides ways to manage lifecycle of virtual machine instances. It helps you to load balance and auto scale to multiple virtual machine instances as the demand increases. One can attach storage and network drives to save data and allows you to manage network connectivity and related configurations for your VM instances. Apart from these, Compute Engine integrates well with Google Cloud technologies such as cloud storage, GKE, and BigQuery, with a transparent pricing and discounting options, including sustained use of savings, committed use discounts, and preemptible instances. Now let's talk about the machine family and types. So, what type of hardware do you want to run your workloads on? To help you decide this, GC provides machine types. Each type of machine is designed for a specific workload use case. Like as we can see, we have general purpose, memory optimized, compute optimized, and accelerator optimized. Each of these family type has a different use case. For example, general purpose provides best price performance ratio for web and application servers, small to medium databases, and dev environments. The memory optimized are best for ultra high memory workloads like large in memory databases and in memory analytics. Likewise, the compute optimized are used for compute intensive work like gaming applications where you need more CPU power. Accelerator optimized are ideal for massively parallelized CUDA compute workloads such as machine learning, high performance computing, best for the workloads that require GPU. Once you select the machine family, then you choose the machine type. And machine type defines the configuration set of your VM instances, which can satisfy your workload needs. So, points to consider while choosing the machine type is like how much CPU, memory, or disk you want. There are variety of machine types available in the GCP. So let's take an example. Like we have a E2 standard 2, right? So E2 here stands for the machine type family. Standard stands for the type of workload, and 2 is the number of CPU. The thing to note here is memory, disk, and networking capabilities increase along with vCPUs. So we had taken an example of E2 standard 2, where the number of CPUs is 2. So this might have less memory, disk, and networking capabilities. But as we move forward with the number of CPUs, these memory, disk, and networking capabilities increase for your VM instance. So you have to consider this as well. So what operating system and what software do you want to install on your VM instance? For this, you might need images, right? And GCP provides two types of images. One is public image and the other is custom. Public image is nothing but these images are provided and maintained by Google or open source communities or third party vendors. For example, Ubuntu, Debian, Windows, all these. Custom images are created by you for your own projects. Let's say you want a specific image type and you need some softwares to be pre-installed, which are not present in the existing public images. In that case, you will go with the custom. Now let's talk about the internal, external, and static IP addresses. So GCP provides three types of IP addresses. One is internal, the other is external, and the third one is static IP address. External IP addresses are internet addressable. That is, one can access the machine publicly, like the way we used to access any website publicly. So these machines, the IP address is accessible publicly to anyone. Then comes internal IP addresses. So these are the internal to a corporate network. One thing to note here is you cannot have two resources with same public IP address, that is external IP address. However, two different corporate networks can have two resources with the same internal IP address. So this question might be asked in your GCP exam. So you have to take a note of it. And all VM instances are assigned at least one internal IP address. Also, creation of external IP addresses can be enabled for VM instances, but when you stop an VM instance, external IP addresses are lost. So this is a problem with the external IP addresses if you are not like assigning it on the fly. So usually external IP addresses are created once you create a virtual machine instance in your GCP environment. How can we address this issue? The way to address this issue is to have a static IP. Static IP can be switched to another VM instance in the same project, and static IP remains attached even if you stop the instance. I'd repeat, even if you stop the instance, these static IP addresses are still attached to your VM instance. You have to manually detach it in order to save money. One thing to note here is you are billed for a static IP address when you are not using it as well. So you'll be still billed if you have a static IP attached to any of your virtual machine instance or MIGs, machine instance groups. So it is recommended that if you are not using static IP, better you release it immediately to save the cost. Now let's talk about ways to reduce steps in creating VM instances. So there are three different ways. One is startup script, the other is instance template, and the third one is custom image. Startup script provides a way to enter commands at the time of provisioning a VM instance, using which one can run installation scripts when machine boots up. And the process of installing OS patches or software when a VM instance is launched is called bootstrapping, where you install the OS patches or softwares while your machine boots up. So this process is called bootstrapping. So startup scripts in general are used just to install a software on the fly through scripts. So there's a startup script provided in the creation window of your VM instance, and that's where you provide your scripts, and when your machine boots up, it will automatically install those things or do the things based on your command, which is provided in that input panel. Then comes instance templates. So instance templates provide a way through which you automate the process of manual selection of machine types, images, labels, startup scripts, and other networking related configurations at once, and use that template to provision more VM instances as and when required with just limited set of inputs. You use it when you need to provision same type of machine again and again to reduce the mundane task. It is used to create the VM instances and MIGs, managed instance groups. So instance templates provides you a way through which you can automate the same step again and again, which you usually do to create your VM instances. So through instance templates, you can directly use the template to create a new VM instance without going through the whole process again and just by providing limited set of inputs. So this actually saves time. And at last, we have custom images. So custom images is used to reduce the launch time of VM instances. How? Usually installing OS patches and software at runtime of VM instances can increase the boot up time, right? And to address this issue, custom images were used. So these images can be created from an instance, a persistent disk, a snapshot, another image, or a file in the cloud storage. These can be shared across projects, and recommendation is to mark the old images as deprecated when you create a new one based on that. This type is also used when you have custom corporate security standards and want all the images to follow them. Then, usually corporate or enterprises use custom images. And the and this process is called hardening an image. Why they call hardening an image? Because you are imposing your corporate security standards or policies in that particular image. So those images are called hardened images. That's it for now, and thank you for watching till the end of this video. Please like, share, and subscribe to my videos. Your likes motivate me and create more content. In the comment section, post what you want to hear about. I'll try to make the content around it. And that's it for today. We'll meet with a new topic and a new video. Till then, have a good day and stay happy.